Okay, so we're looking at question 6 from worksheet 3. As you may recall, we were talking about left-handed people, people with glasses, and people with brown hair. And when you work through the process, like I said, I'm just going to jump to this part of the solution since I've already published it. You end up with 6, 4, 3, 2, 1, 1, and 9. So check out the video if you want to see how we got there. And there were a total of 17, 15 for glasses, and 7 were left-handed. So once you got the Venn diagram, then the process of answering the rest of the questions was fairly straightforward. It said, express each of the following statements using set builder notation. Choosing a person who wears glasses and is left-handed. Probability, somebody wears glasses, I'm using G for that set, intersecting with left-handed people. So since we've got an and in the statement, we're looking for an intersection. Part 2 asked for choosing a left-handed person who wears glasses or has brown hair. So probability of glasses or brown hair. So it's a union because we're looking at an or. And part 3 says choosing a person who has brown hair and wears glasses or a left-handed person who has brown hair. So this one's a little more complicated. So we're looking for the probability. Now they've got, think about this, they've got two ands and an or. So the first part is brown hair and wears glasses. So I'm going to put this inside another set of brackets, brown hair and wears glasses. And then it's an or, a left-handed person who has brown hair. So it's a left-handed person who has brown hair. So the brackets became important here because they're describing one person here who's got, or one type of person who has brown hair and glasses, and then the second person who is left-handed and who has brown hair. And it can be somebody from either category, so that's why we've got the or symbol in the middle. Part C. It says to calculate probability of A union with B. So we're looking at our, whatever our A group is, which is choosing left-handed people, and our B group, they define to be the people who wear glasses. So very simply, you're looking at your Venn diagram, looking for how many people are in A. They tell us right away there's 17 people, and the total, I didn't write on here, we're told there are a total of 35 people. So it's 17 out of 35. Question 2, probability of A intersecting with B. So that's the people who are both left-handed and wear glasses. In this case, we're looking for the intersection, so that's these people and these people. So if there's a total of 5 out of that 35. 3 is the probability of A union B union C. So they can be in A or B or C. I forgot that there are 9 people outside of each of those sets. So there are some people who are not left-handed and they don't have glasses and they don't have brown hair. So in this case, we're looking for the probability of A or B or C. So essentially anybody who's in any of these spaces. And if we add everything up there, we get a total of 26 out of the 35. 4, probability of A intersection with B, intersection with C. So if we look at A intersection B, that's this space here. And then they're asking where does that space intersect with part area C? And that would be then, this is the area where the two of them intersect. So in this case, the brackets weren't that relevant because the intersection of A and B and C is right in the center. So we can say that it's 3 out of 35. And part 5 asks us for the probability of A union B intersection with C. Okay, so A union B means anything that is in A or it's in B. So it can be any of those people that you would be choosing. But then they're asking where does that shape intersect with C? So we're looking for where those two places that we defined overlapped, and we should be finding that it's these spaces in here. We add them up, we've got 8 out of 35. Oh, and there's one more, part 6. Probability of B intersection C union with A, which is equal to 11 out of 35. So how do we get that? The intersection of B and C, intersection of B and C is here, and then that's union with everything that's in A, so everything that is possible in A. So if we add those all up, we get 7, plus 1 is 10, plus 1 is 11, which gives us 11 out of 35. Part D, we're asked to calculate the probability of choosing a person who wears glasses but doesn't have brown hair. Look at this, so we're looking for somebody who wears glasses but doesn't have brown hair. So they can't be in the brown hair space. So if you think about that, that means this space in between is the area that's being excluded. So based on that, we end up with 2 plus 6, 8 out of the 35 possible choices. Part 2 says we're looking for the probability of choosing someone who doesn't wear glasses and is not left-handed. So if you think about people who don't wear glasses, that's everybody who is outside of the glasses and is not left-handed. So it has to be everybody that's also outside of left-handed. So if you think about that, then that's everybody who is outside of those spaces. So based on what you see there, we end up with 9 from the brown hair people and 9 who don't fit any of the other categories. So we've got 18 out of 35. And the final one there, number 3, the probability of someone who is left-handed but doesn't wear glasses and doesn't have brown hair. Okay, so the probability of somebody who is left-handed, so they're in A, but doesn't wear glasses and doesn't have brown hair. Okay, so let's look at that. So they're left-handed, have to be in our left-hand zone, but they're not allowed to wear glasses, so we have to eliminate those people, and they don't have brown hair, so we have to eliminate that person. Just leaves us with one possible answer, just 1 out of 35.